Hello all. In this video we will solve a problem on corner bracket. The bracket is made up of steel with a Young's modulus of 205 GPa and the Poisson's ratio is 0.27. The upper left hole is constrained around its entire circumference. So this one is constrained. The lower right hole is loaded with pin loaded by pin with a pressure of 50 bar to lower half of the circumference. That means only this lower half of the circumference is loaded. Okay, only this lower half of circumference is loaded with a 50 bar of pressure. Find the maximum deflection and stress in the bracket. The bracket thickness is 10 mm. So they have given in here. So how we are going to model this and solve it. So first you need to create this geometry, right? So how we are going to create the geometry like this. So first you will take this much portion. Okay, so you need to create a rectangle with a width of 150 and height of 50 mm. Then you will create this portion. Okay, 50 mm height and 50 mm width. Then you are going to create a circle here with 25 mm radius. Then you are going to create a circle of 25 mm here, radius 25 mm. Okay, so that means the diameter will be 50. Then you are going to fillet this around here. R is equal to 10 mm, that means radius of 10 mm you are going to fillet this. Okay, then you are going to create a hole of 25 mm diameter, or else I can say 12.5 mm radius, and then you are going to create a hole at this point. Then you're going to constrain at this location, and you're going to apply load for this half of the circle. Okay, so we will see how to solve this using ANSYS APDL. Let's go to ANSYS APDL, preferences, structural. Okay, preprocessor, element type, add solid, quad 4, node 182. Click OK. Options, you need to change K3 plane stress, width and thickness. Click OK. Close this thing. Real constant you need to add with a thickness of 10 mm. Click OK. Close this thing. Material properties, material models, structural linear elastic isotropic. Here 2.05 e to the power 5. And this one is 0.27. 0.27. Click OK. Now you are going to model this, create areas, rectangle. So you can go by dimension also. Now I'm going to create this by two corners. Okay, so width I have 150, and height I have 50. Okay, so now we have created this, and another one. So this one, it is at a 100 mm from origin. Okay, this portion is 100 mm from origin. So 100, width is 50, height will be, this is downwards from the origin, so it will be minus 50. Okay, so now you can see. So now you have to create a circle for this two ends. Okay, here also and here also. So go to circle, solid circle. So you can calculate the dimensions, or else you can just move the work plane, offset work plane to midpoint of this. You can see here the work plane is here now. So now go to circle and create a circle of 25 mm radius. Click OK. You can see. And also, if you are going to create a circle here, then you need to move the work plane here. Click OK. And you can see the work plane is here. Click, the radius will be 25 mm. Click OK. Now you need to merge all these things. Okay, so go to operate boolean add areas. So pick all the areas and merge this. So this is whole plate now, and now you need to create a fillet here, right? So go to create lines, line fillet. Okay, so for that you need to plot lines, as you can see here, and create these pick these two lines to create fillet of radius 10. Click OK. Now you can see the fillet, and you need to create this area also. How we will create this area, arbitrary area through by lines. Okay, so click here. Okay, front view, and you can see there are three lines. You need to create these three lines and create the area out of it, and you need to merge this area and this area. So go to again operate boolean add areas, pick all. So now it is created. You need to create two holes, one here and one here. So now you have the work plane here. So just go to create areas, and go to circles, solid circle, and circle of radius 12.5. Click OK. Now you can see here the circle is created. Another circle should be here. The work plane should be moved. Okay, so offset to key points here to here. Click OK. Now the work plane is here. Go to solid circle and 12.5. You need to give the radius. Click OK. So now you need to uh, apply boolean and remove these two circles. So go to operate booleans. Now you need to subtract areas. So you need to retain this plate. Click OK, and you need to remove this. Click OK. Again you need to retain this plate, and you need to remove this circle. Click OK. Now the whole geometry is over. So now you need to apply loads, define loads, apply structural displacement on lines. You need to plot lines now. Plot lines here. You need to constrain in all the degrees of freedom. Click OK, and go to pressure on lines. Here you need to select only the half of the circle. Create OK. You have the 50 bar pressure. Click OK. Now you can see the load is applied. Okay, so before this load, need to go to meshing. Okay, anyways I have applied the load. Now I'm going to mesh this thing. Meshing, mesh tool, mesh, pick all. So the meshing is also done. After the meshing only you need to apply the loads. Okay, anyways, so now go to solution, solve, current LS. Click solution is done. So now you can see the results, plot results, contour plots, element solution, stress, on measure stress. Click OK. Now you can see the maximum deflection and maximum stress, nodal solution, deformed solution, y component displacement. Also you can see the displacement. You can also animate this. Okay, so just once again create this geometry and solve. Okay, and verify the values. That's all for the day. Thank you.